Hello and welcome to this CATIA prismatic machining video. We're looking now at the machining of setup 2. If you've been following the video sequence, you would have set up an operation for facing. So if we go to setup 2 into 3, you will see that you should have a facing operation. The next operation that we're going to do is a profiling operation. So if we look at what that might look like, this here shows you can see in green here what we want to the surface we want to generate. So in other words, we're trying to remove material on the outside of this using a profiling operation. So there are a couple of things to bear in mind when you do a profiling operation. We've talked about this in an earlier video. I'm going to go ahead and hide that green surface. I'm also going to hide the stock temporarily. So one of the things we mentioned is we need to look at areas where the cutter goes into a sort of a concave region to make sure that the cutter radius is appropriate. So we use the measure tools here to measure. So this tells us that we have a radius of 0.436. So a cutter diameter of 3/4 of an inch would work in there. The other thing that we want to pay attention to is how much material do we have this way, because we're not going to be able to take all this material in a single cut. We have to use multiple radial passes. So I'm going to measure the distance between this face and this face, and it tells me that that's 5/8 of an inch, or 0.625 distance. So that gives me a little bit of information about the size of the tool, and also too, for my machining toolpath strategy, how much of a step over can I take, and maybe how many passes do I need to take radially to remove that material. Okay, so with that, we're going to go to our setup, and we're going to just jump right into this. I'm actually going to let you go ahead and do this as an exercise first, since you've already done a profiling operation in the first setup. So here is what we did for the first setup. So using the same parameters, the same cutting tool. So in the first setup, if you recall, we used a 3/2 inch end mill. So we're going to work with a 1/2 inch end mill. Of course, that will work in the corners. So using the same tool, using the same approaches and retracts, and also the same speeds and feeds and toolpath strategy. So I'll let you take a shot at this first, and then we'll come back and you can look at how I've done it, and you probably need to make some changes to some of your choices once you've done that. Okay. So hopefully that went well for you. So let's go ahead and step to the process of adding that operation. So again, we're going to add it, of course, to our second setup. So we go over here to our operations toolbar, and we select profile contouring, and we add it below the facing operation. So the first step is to go ahead and define the geometry. So to do this, I'm going to hide the stock because I don't really need the stock. At least not initially. So let's go ahead and hide this. So the first thing we pick is, where does the tool first hit material? Remember, we faced off material down to this surface, so this is where the tool will first make contact. And then we want to go ahead and select the guiding elements. That tells us what the profile is that we want to machine to. So let's go ahead and select this. And again, I'm going to use the edge selection tool. So if you remember the edge selection toolbar here, we can go ahead and select an edge. And previously I showed you that once you select an edge, you have some of these tools that help you select a loop or multiple edges. So in this case, I want to use the option to navigate on edges until an edge. And then if I look at this arrow here, it says that CATIA is going to go around. It's going to actually select edges in a clockwise direction. So let's go ahead and select this edge here. And my hope is that CATIA will be smart enough to loop all the way around and come back to this edge here. So let's see what happens. So it looks like it got to this point here. So it didn't quite get all the way around. So it got confused at this point here. So let's repeat this and see if we can get back here. So I'm going to click on this again, and hopefully I can extend the selection all the way through. So there you see I can very quickly pick a lot of edges without having to go through and manually picking each edge individually by using this navigate on edges until an edge. So let's hit OK. So we now have our guiding elements picked. Let's go ahead now and pick the bottom. So this is a pocket, a profile that has a bottom, so the tool will ride on the surface. So let's select that as our bottom. And these are limiting surfaces. Again, we don't have any limiting surfaces since it's a full circuit that the cutter is going to do. Okay, so this is our geometry. Let's go to the third tab. It looks like CATIA is trying to use the facing cutter. Of course, that's not correct. So let's go ahead and change the tool that we want to use. So let's select the tool from the document. And in this case, we're going to use the 1/2 inch carbide tree fluted end mill, which is the same tool that we used in the first setup. So let's go ahead and select that. And we can see that in selecting that tool, CATIA actually took that profiling operation, which was previously being machined as part of the facing cutter tool change. It inserted a new tool change for that end mill, and now it's added the profiling operation under that tool change. So that's our tool selected. Let's go over now to our fourth tab, which is our process parameters. So we want to make sure here that we have the right information. So this comes in from the cutting tool, the machining roughing feed rate, which is 120 inches, and our finishing feed rate, which is 20. The approach and retract look like the values that were set for the facing operation. CATIA remembers these. We're going to stick with those. And then our RPM is 6,000 revolutions per minute, which is what we use for carbide. So these look good. Let's go over to our fifth tab, and these are our approaches and retracts. So if you recall, in the first profiling operation in setup 1, we used a circular lead-in and a axial move for our approach retract, as well as we also had return between levels because we were stepping down multiple levels to get down to our depth of cut, and we also had a finish pass, retract, and approach. So let's activate these just to remind us that we have to do these. And let's start with our initial approach. So we want to do a circular lead-in and a axial move. So this is a move from a plane, so we want to delete this. So let's remove all motions, and let's go ahead and add a circular motion. We left the default radius. Again, you can change this if it's too long. Make it smaller if you need to. And then we added an approach move, axial approach move to the start of the circular lead-in. So we use this axial move here, axial motion. Now, if you recall, in the first setup for that profiling operation, we used 0.125 as our axial. Again, the rule of thumb is that you should use a approach motion axially that is slightly greater than the depth of cut. For the profiling operation in the second setup, we're probably going to have to take fairly large radial passes. Our step over, our radial engagement is going to have to be larger than the first setup. Remember, in the first setup, we were only removing a little bit of material around the outside. So in this case, I'm going to probably use axial depths of 50 thousandths to step the cutter down. So in this case, I'm going to use an axial approach that is slightly greater than 50 thousandths. Let's use 75 thousandths. So again, this is because we're taking smaller depths of cut in this second setup, or we will be, than we were in the first setup. So that's our approach, and we're going to just do the same thing for the retract. We're going to delete what's there, add a circular, add an axial, and then double click and make this 75 thousandths. And again, we can come back and change these if they do not look to be correct. And let's just repeat this for the finish pass, retract, the approach, and then the return between the levels, retract, and the return between levels, approach. Okay, so we have the initial approach retract, and we've activated 2 other pairs. We may have to also do something else on here, but let's move ahead first. We can always come back and add these later on once we see what the tool is doing as it engages the material. So let's jump now over to the first tab, and in here we're going to use a one-way strategy as we did in the first setup. We're going to leave the direction climb, type of contour circular, which is going around corners. Again, we don't have corners, sharp corners here, because they are rounds on the corners and fillets. If we look at these options here, we do want to close the toolpath. So let's close it. And let's do a little bit of an overlap, 50% of the tool. That's fine. The remaining options are not important here. For step over, remember there are 2 types of step over. There's radial and axial. So for the radial step over, again, the question mark will explain to you what this means. We have a question here of how many paths do we want to use. So remember, when we measure the distance between the edge, this face here, and this face, we found it to be 5/8 of an inch. And if you recall our cutter diameter, we're using a 1/2 inch cutter. So there's no way that we can take this in one pass, radial pass. And even if we could, we may not want to do that because of the cutter load. So we need at least 2 passes here. Again, this question mark shows you. So let's bump this up to 2. And then the distance between passes, since we have a 1-inch cutter, or sorry, 1/2 inch cutter, let's go with 50% radial engagement. So let's use 0.25. And again, we may have to adjust this. So again, the question mark shows you what this means. But let's start there, and then we can always work our way by modifying this. So that's our radial step over. So that's the cutter moving inwards. And then we want to adjust our axial. So this is how the tool changes depth. So again, the sequencing here, just to recap this one, I stepped over this. Again, the question mark shows you that we're going to go radial first. So we're going to cut 1, move to 2, then 3, 4, 5, 6. So this was set correct. So for our axial strategy, we want to go maximum depth of cut. We want to go a maximum depth of cut of 50 thousandths, and this tells you the number of levels. So Katia calculated the number of levels given the distance from the top of the profile geometry to the bottom. So it's quite a few levels that have to be cut at 50 thousandths to get where we want to get. So these other options here are not important for what we're trying to do. Let's go over to the third tab. We want to add finishing pass. We want to add a finishing pass at the last level and bottom. So what this means is that we're not going to finish each level. Remember, we have 26 levels. So it would mean that a finishing pass would be added to each one of those 26 levels if we were to do side finish at each level and bottom. We just want to do a finishing pass on the bottom when the tool is at its lowest level, and then also to finish the bottom too. And we want to have a side finish thickness. Again, the question mark shows you what this is. So this is how much we're leaving. And we're going to set this to 10 thousandths. And some of these options here are for other things that you might want to do, but the one that we want to set is the bottom finish thickness. So the top one and the bottom one, and that's already at 0.1 or 10 thousandths. Okay, so let's go ahead and generate our tool paths. And there we go. So what you can see here is that the cutter is taking 2 radial passes. So the cutter starts on the outside, and then it moves inwards to the next pass. And once it's got these 2 passes done at each level, it drops downwards. If you change your toolpath display option to plane by plane, and then rewind, you can see clearly what's happening on each level. So as we step through, we're now stepping through and seeing what each level does. So this here shows you the initial approach from tool change, this dashed line, tool stops 75 thousandths. Remember we set our axial approach in our macro to 75 thousandths. So it approaches at the approach rate, and then it moves into a circular lead-in. Then the green is the actual machining at the machining feed rate. So that's the first level. Then the tool, once the tool gets to the end of the first pass, it now repositions to do the pass that's closest to the final wall that we want. So the tool rapids up, rapids over, and rapids down. Now this is a little bit concerning, and we may want to tweak this in a little bit, as I will show you. But let's continue. So now the tool completes that inner pass. So it runs all the way around the second pass. The tool comes out, so this is the retract move. And now it repositions down to the next level. So this is the tool retracting, rapiding, and now dropping down to the level that's 50 thousandths above the first. And then pretty much it repeats. So here's the lead-in again. The circular lead-in runs around the part. Then it repositions to the second pass radially, the one that's closest to the wall. And then it does that pass, comes out. So this is the retract in a level, or the retract between levels, sorry, because this is how it gets to the next level. It comes out, it retracts 75 thousandths, rapids over, rapids down, and engages 75 thousandths. So again, I strongly recommend you use this plane by plane option to look at what's going on. This is the way you visualize how the tool is removing material at each level. Now I'm going to step back a bit because there was an issue here between, so this here which shows how the tool repositions between the outer radial pass and the inner radial pass. Remember that we've set it to be 2, and this is done totally using rapids. So this is a little bit concerning. Anytime you wrap it up and then wrap it down, and notice that there isn't any yellow here. So the tool is rapiding down to this tool pad. So that's of course a danger sign. Anytime the rapid stops on your green means that the tool is rapiding into material down to your depth of cut. So we need to fix this. So the question is, what macro or what lead-in or approach and retract impacts the tool as it moves between parts of the tool pad at the same level. So let's hit OK, and let's go back to our 5th tab. And it's probably one of these options here that has not been set. So if we look at these options here, we see that there's something called return in a level retract, return in a level approach. And what this means is, how does the tool approach when it moves from one piece of the tool pad at the same level to another piece of the tool pad at the same level. So we want to activate these two, and again they activate as a pair. And let's go ahead and just set these to be the same as we did for the return between the levels, which is we had a circular lead-in and then an axial motion that is greater than the depth of cut, so 75 thousandths. And then let's do the same thing for our retract. And let's look at what impact that had. So now that we've added these, let's go ahead and regenerate our tool pads. So it looks a lot busier in here. And let's rewind to the start, and let's step 2. Make sure that you're on plane by plane replay. So again, this is the first approach. So this is the outer pass. So we come around and then we retract. And now the tool is going to reposition for the inner pass. So that's the one that's closest to the wall. And we see now that instead of it being fully red, we now have a blue retract. We have a red rapid, and now we have this yellow here, which tells us that the tool is moving downwards at the approach feed rate. And it's doing so at a speed that is the approach feed rate. And now we see for the inner pass, we now have this yellow approach, which we didn't have before. And the tool then moves around in a clockwise direction and then comes off. So these are basically, this is basically what's happening on the first level. 50 thousandths down. This first pass on the outside radial, and then we step in, we complete this, step in, and then do the pass that's closest to the surface that's being machined. The other thing that you may want to check is the finish pass. So another display option that's really useful, instead of the plane by plane, you can come down here to the bottom and look at what's called sectioning of tool paths. So let's click on this. And what you see displayed here are all the levels that tool paths have been generated on. And by clicking on one of these levels, you actually see all the tool paths on each level. So again, you can see the two passes, the lead-in in yellow and the lead-in or retract in blue. So what we want to do is look at the last level, because the last level, of course, would be our finishing pass, just to confirm that we have the correct lead-in and lead-out. So if we click on that very last yellow plane here, we have our yellow lead-in to the light blue. The tool comes off, and then it lifts up and repositions over here for the second pass and completes the second pass. Okay, and we have, of course, the option to do our replay using material removal simulation. And this might be important to check and make sure we're not leaving any material in the corners. So let's go ahead and run this. Sorry, we have to switch this to continuous playback. So there's our facing operation. So we are in fact leaving material in the corner, which is something that we're going to have to deal with. So there we go. We're also leaving material here. So there are a couple of strategies one can use, and we would probably not get into those fully in this video. But one thing we could do is we could go back to our strategy tab here and change our step over. So remember, we have 25 quarter of an inch between tool paths. So let's say we wanted to increase this outwards to 3/8. Let's go ahead and generate. And let's repeat the material removal simulation. So we removed this, but we're still not quite there on the corners. So that's that remains an issue. So what are the options? Well, one could increase the size of the cutter. So if you went from a half inch to a 3/4 inch, you'd be able to take a wider path, and that could potentially do it. The problem with doing that, though, is that we tend to want to avoid using larger cutters because if you have an accident with them, they tend to do a lot more damage, and they also cost more, of course. The other thing that one can do is one can increase the number of paths. So instead of 2 paths, we can use 3 paths. Let's change this back to quarter of an inch. So this, of course, is going to increase your time. So now notice that there are 3 passes here instead of 2. Let's look at the simulation. So again, it's still leaving the corner. So let's go ahead and pause this and close, hit OK. And let's go back to 3/8 of an inch. So now we are getting the corners, but notice if you look closely, let's just pause this here for a second. Notice that the cutter, as it's going around the first pass, it's hitting the corners correctly, but it's not doing any work here. So this is really inefficient because remember, we're doing this at 26 levels. So while this is certainly going to give you the result, when you talk about your machining time, it's going to be less efficient from that perspective. There are, as I said, other strategies. You can increase the size of the tool. The other thing you can do is you can, when we talk about pocketing operations, you can add a pocketing operation to clean out corners. So having four operations that do those locally so that the tool focuses in these regions, and then you can maybe get away with 2 passes. And at the end of the day, it all depends upon the machining time, which one comes up with. And the machining time is depicted here. So we can see here that it's going to take quite a bit of time, almost over half an hour, to machine all these passes. So again, there's that consideration of the time to do this that needs to be brought to bear. Okay, so again, this is a how you would set up the profiling operation on the second setup. Very similar to the first setup, however, there were some other additional considerations, the number of passes that we needed to take being one of those. And in the next set of videos, we'll start looking at how to do the pocketing operations. Again, hit OK to commit it to the tree. Do save your file as you progress through these videos.